Alright guys, in the last video my computer shut down, so we'll continue. So I'm graphing this like it's cosine, so it started at a max, and then I'm going to go through the midline at 1/2, and then down to a min at 1, midline, max, and I'm just going to keep doing this, midline, min, midline, max, midline, min, and midline. And I'm going to continue it on the other side until I fill up all of my graph here. Okay, now I'm not going to connect this like it's cosine because our graph really isn't cosine, it's secant. So I'm going to use what we looked at in Desmos to kind of just get the rest of the graph here. So anytime we have a 0, okay, anytime the cosine graph equals 0, which is going to be when the cosine graph has a midline point. Okay, so one more time. Anytime your cosine graph that you've graphed, okay, the points for the cosine, has a midline point, that is going to indicate an asymptote in the secant graph. So at every single one of these points where I have a midline point, I'm going to go put an asymptote for the secant graph at every single one of them, okay? So at all of those values, I have an asymptote. And then to finish the graph, I'm going to say, okay, I know, or I saw that all of these maximum points that were on the cosine became little minimums for these little parts of the secant. So at every single time I see a max, I'm going to go make that like a little min for my secant graph. And every time I see a min, that's going to become a little max. Okay? And so this is what my secant graph looks like. Okay? So that's the finished secant graph there. And now that I have a graph, it's a little easier to see what the domain is going to be. So let's go talk about the domain. So the domain, I'm going to actually come down here and write a little bigger. The domain is going to be x belongs to, I'm going to start, actually let's do the domain second. Let's do the range first. So the range is going to be the y belongs to, and I'm going to start from the lowest part. So I'm going to start from the very bottom. Okay, so from negative infinity, these guys keep going forever. So from negative infinity up to this maximum point of the secant graph, which is at -4, and I want to include that. But then I have a gap, okay, so I'm going to put a little union here, and I start back up at 2 and go to positive infinity. So the range is a little bit easier to find than the domain. So let's go talk about the domain now. Okay, so I'm looking at the domain, and I'm seeing that everything is fine. All the x values are going to be fine here, except where the asymptotes are. Now, again, there are infinitely many asymptotes here, but the first one, so typically the way you're always going to write your domain is you're going to start by saying x has to belong to the set, or I'm going to actually say x can't equal. It's easier in these to say that x can't equal the asymptotes than it is to say every single one of these little pieces of the graph. So x is not going to equal 1/2. That's our first asymptote, okay? And typically you're always going to start with saying what the first asymptote is. So it's 1/2 here. And then I'm going to look at how do I get from 1/2 to 3/2? How much space is between those values? Well, technically 1 unit is, because 1/2 plus 1 is 3/2. And then 3/2 plus 1 would be 5/2 or 2.5. And 2.5 plus 1 would be 3.5. So I'm adding 1 every single time to get to the next asymptote. So I'm going to say plus n, where n is an integer. Now think about integers that we could put in for n. So I could plug in 1, and that would get me to this next asymptote after 1/2. I could plug in 2, and that would get me 2 asymptotes later. If I plugged in 3, that would give me the asymptote 3 asymptotes later. An integer is also a negative number, so if I plug in a -1 here, 1/2 minus 1 would be -1/2, and that gets me these negative asymptotes. If I plug in -2, I would go back 2 asymptotes, okay? And so this is the easiest way to represent our domain here, is x just can't be where these asymptotes are. Now, the other thing that I'm going to finish up really quickly are my points here. So 0 at x equals 0, my y value is 2. At 1/2, it's undefined because there's an asymptote there. At 1, it's down at -4. And then back to 3/2 is an asymptote, so it's undefined again. And then 2 ends at 2. Now, the cosecant is very similar. So when we graph the cosecant, you might have already guessed that we're going to have to graph the corresponding sine graph. Okay, and we again know that cosecant is like 1 over y or 1 over sine, since sine goes with y. And then same reason, we can't have 0 in the denominator. So when we do, we have a vertical asymptote. All right, so let's go look at the graphs of this really quickly. Okay, so the graphs this time of sine is here, and the graph of cosecant is here. And so we can kind of see the same thing going on. So when I have a 0 in the sine graph, I can see there's an asymptote there. When I have a 0 in the sine graph, I see there's an asymptote. Okay, and so these look like they're happening not at multiples of pi over 2, but at multiples of pi. Okay, and then same thing happens here. When sine has a max, that becomes a min, okay, on the cosecant. And when sine has a min, then cosecant has a max, okay? All right, so let's go look at where the vertical asymptotes are. So we saw the vertical asymptotes were at positive and negative pi. There was one at 0, 0, positive, negative pi, positive, negative 2 pi, and we could keep going, okay? But I can see that these are just happening at multiples of pi, okay? So our first asymptote is actually at 0, so I could say 0 plus pi, or I could just say at multiples of pi, so pi n, where n is an integer. And we'll again go over an example of this. Now, let's look at this example here. Okay, so I'm going to go do everything for this graph like it's a sine graph. Okay, so first 4 things here, just like it's a sine graph. And then again, we'll come back to the domain and the range. So the period, the b value is 1, so 2 pi over 1 is just 2 pi. The amplitude is a fourth. I don't have a shift up or down this time. Okay, so that's nice. And then the phase shift is going to be right pi over 2. Okay, so I don't really need to see where my new maxes and mins are because this has not changed since I haven't shifted it up or down. But I do need to go see where my new x values are going to be after that shift. Okay, so my old x values and my new x values I'm going to go find. So I would normally start at 0. And then I would end at 2 pi since that's the period. And so halfway to 2 pi is pi, halfway to pi is pi over 2, and this is going to be 3 pi over 2. And so to each of these values, I'm going to actually, since I'm moving it right, I'm going to add pi over 2. So to all of these, we add pi over 2. Okay, so let's go see what this is. So 0 plus pi over 2 is just pi over 2. Pi over 2 plus pi over 2 is pi. And then pi plus pi over 2 is 3 pi over 2. And we can probably see a pattern here. So I've got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 would be 2 pi. And then this would be 5 pi over 2. Okay, so my new x values are going to be at pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2 when we shift them to the right pi over 2 units. Now, let's go look at what that's going to make the graph look like. So, I'm going to say, okay, well, it's probably easiest to just scale this graph by pi over 2 units. So I'm going to let each of these be pi over 2. So here's pi over 2. Here's pi, 3 pi over 2, 2 pi. Okay, and then this is going to be 3 pi, 4 pi, 5 pi. And I'm going to go back in the other direction, negative pi and negative 2 pi. And then 1/4, I'm going to actually spread this out a little bit. So I'm going to let this be 1/8 and then 1/4. And then negative 1/8 and negative 1/4. Okay. So now when I go to start graphing this, I'm graphing this like it's a sine graph. So I'm going to start at my new start point. So I have to remember that this is like my new start point right here. Okay, so sine starts at a 0, so I'm going to start this at pi over 2 at 0. And then it's going to go up to a max, 0, min. And so here's my 1 period of pi, or of sine, that goes into, that matches up with these x values of the table. And so then we're going to continue to just put these points in, as many as I can fit. Okay, so back this way, sine went up first on this side. It's going to go down here. And there we go. So I'm not going to actually put in my sine graph here. I'm not going to connect these points because remember this is not an actual sine graph. It's cosecant. So I'm going to go put in now any place where my function has a 0, I'm going to put in asymptotes. So all of these zeros, anywhere that the sine is 0, okay, or we have a midline point, that's going to become an asymptote. So all of these values are asymptotes. And then any point that is a max becomes a little min, okay, for the cosecant. So this is what we have for our graph. Okay, so there's my finished cosecant graph. Now we need to talk about the domain and the range. So let's do the range first. So we're going to go from negative infinity up to negative 1/4, and I'm going to include that. And then from positive 1/4 to infinity. Now, the range, or the domain, so we're going to say we don't want x to equal these asymptotes. So these asymptotes are happening, it looks like at pi over 2. Now, I want to be sure to make a distinction. So when we shift, normally the function's going to have an asymptote at, like we said, at 0 and pi and 2 pi. Okay, so 0, pi, and 2 pi. This is the parent function. This is where sine, the original sine, or the original cosecant, has asymptotes. However, if we shift the function, okay, like we did, so we shifted it. So the asymptotes also shift. So my asymptotes are no longer at multiples of pi, they're at multiples of this shift, okay? So pi over 2, and then 3 pi over 2, and then 5 pi over 2, okay? But I can still see that the asymptotes are pi units apart. So I'm going to say x can't equal pi over 2 plus multiples of pi, where n is an integer. So let's think about it. If I take pi over 2 and I add 1 pi, okay, that's going to put me at 3 pi over 2. If I add 2 pi, that's going to put me down here at 5 pi over 2. If I plug in negative 1, that takes me back to negative pi over 2, okay? So this is our domain. X can't equal any of those values. And so you'll have some homework problems. This is lesson 5, by the way. So you'll have some homework problems to practice these kinds of graphs.